power source for the DC distribution system is 4 engine-driven generators. The generators supply power directly to the master bus. Highlighted are the control, voltage regulation, and protection systems for the generators. Cockpit controls and instrumentation that are associated with the generator operation are the generator switches, the generator ammeters, and voltmeters shown here in the upper right. With its associated selector switch, all of these are mounted above the first officer's sliding window on the generator panel. The 4 generator switches provide a means to connect or disconnect the generator output to the master bus through the line switch relay. The generator switches are normally left in the on position as shown. With the switches in the on position, the generator will automatically connect and disconnect itself from the master bus under certain operating conditions. The generator can be manually disconnected from the master bus by placing the generator switch in the off position. The generator panel with the 4 generator ammeters monitors the individual load in amperes from each generator. The DC voltmeter, calibrated from 15 to 30 volts DC in conjunction with the voltmeter selector switch, allows monitoring the voltage of the individual generators on the master bus. The normal position of the selector switch is the bus position. Primary power is provided by a 28-volt DC generator rated at 300 amps. The generator may be operated at up to 450 amps for short periods of time if necessary. The output of the generator is to the master bus. The field of the generator is connected to the generator control panel in the voltage regulator compartment to provide a means of voltage regulation and control of the generator output. The DC-6 generator is mounted on the left-hand side of the engine accessory drive section at approximately the 7 o'clock position. The generator is a direct drive unit that operates at about 3 times engine speed. There is no provision to mechanically disconnect the generator from the engine. A blast air tube is fitted to the aft of the generators. Cooling air is provided from a small intake in the oil cooler air scoop. This blast air tube will be closed when an engine firewall shutoff handle is pulled. Generator output load should not exceed 180 amperes when operating on the ground due to insufficient cooling. Generator output is fed through a heavy feeder cable from the generator to the ammeter shunt in the main junction box. From the ammeter shunt to the line switch relay through a short 8 to 12 inch heavy cable. From the line switch relay over a similar cable to the reverse current circuit breaker. The reverse current circuit breaker is bolted directly to the master bus. There are 4 ammeter shunts. 2 each are shown here under each floodlight bracket. They are in series with the generator output and provide the electrical connection to the ammeter. This indicates the load in amperes placed on that generator. The line switch relay operating with the generator switch on the generator control panel will connect or disconnect the generator output to the master bus. The reverse current circuit breaker provides protection for the master bus and the generator in the event of a generator failure, line switch relay, or a short in the generator feeder cable. The generator field is connected to the generator control panel in the voltage regulator compartment. The generator control panel varies the current flow in the generator field to maintain a constant voltage output. The generator control panel is connected to the master bus through the generator control circuit breaker. This control panel will provide automatic voltage regulation and equalization. It will automatically connect and disconnect the generator to the master bus under all normal operating conditions. A generator control panel for each generator is located in the voltage regulator compartment of the main junction box. The generator control panel will maintain generator output voltage at 27.5 volts. It connects the generator to the master bus when the generator voltage exceeds the bus voltage by a slight amount. It will parallel or equalize the voltage output when more than one generator is connected to the bus, and will disconnect the generator from the bus whenever output falls below bus voltage. The generator control circuit breakers, highlighted here on the master junction box, protects the bus from a malfunction or short in the generator control panel and the generator. It provides a source of power to the generator control panel to be used as a reference voltage. This enables the generator control panel to connect the generator to the master bus. The generator is automatically connected to the master bus when the generator output voltage gets slightly higher than bus voltage. This voltage differential is sensed by the generator control panel, lower right-hand box, which then allows the generator voltage to close the line switch relay, upper center. If this circuit breaker is tripped, there is no way for the generator control panel to receive a reference voltage from the bus. Consequently, the generator can never be connected to the bus. When the generator output voltage drops due to insufficient engine RPM, a reverse current flows from the master bus through the generator and to the generator control panel. This small reverse current flow through the generator control panel will cause an interruption of power to the line switch relay through the generator switch, causing the line switch relay to de-energize and remove the generator from the bus. A carbon pile voltage regulator on the generator control panel will respond to the generator output voltage and will vary the amount of current through the generator field to maintain a constant voltage output throughout a wide operating range of generator speeds. This voltage is normally set at 27.5 volts. To ensure an equal load distribution, when more than one generator is supplying the bus, it is necessary to connect each generator control panel to a common bus called an equalizer or paralleling bus. This allows the equalizer or paralleling section of each generator control panel to compare its output voltage with the other generators, thus making adjustments to maintain equal voltage. The equalization circuit is automatically disconnected when the generator is disconnected from the master bus. The reverse current circuit breaker is provided to protect the master bus in the event of a short in the generator output feeder cable. When a reverse current of 300 amps from the master bus toward the generator occurs, the reverse current circuit breaker will open, isolating the master bus. At the same time, it will break the generator field circuit by opening the field switch. This field switch is an integral part of the reverse current circuit breaker and opens any time the reverse current circuit breaker is tripped. The reverse current circuit breaker is located in the top of the main junction box. A small round indicator window on the top of the circuit breaker will show yellow, thus indicating the circuit breaker has been tripped, killing the generator output. This circuit breaker can be manually reset by depressing a reset switch located under a soft rubber cover on the forward end of the circuit breaker. The generator field circuit breaker is one of three protective devices in the generator field circuit. The field circuit breaker will protect the generator in the event of a heavy current flow through the field. This is the only protective device in the generator field that can be manually tripped to open the circuit. As illustrated by the previous slide, the reverse current circuit breaker will also open the field circuit through the field switch. The field circuit breaker located on the right-hand side of the main circuit breaker panel are trip-free magnetic type circuit breakers. They cannot be manually held in the on position in the event of an electrical malfunction. These breakers are used to isolate the generator field circuit during electrical malfunctions or troubleshooting. The overvoltage protector located in the main junction box will trip and remove the generator from the bus should full field voltage occur. An application of full field voltage could cause a bus voltage in excess of 70 volts. The overvoltage protector, when tripped, will also open the generator field, thereby rendering the generator inoperative. The overvoltage protectors, the black boxes shown here, are located on the right shelf inside the main junction box. When a protector has been electrically tripped, it may be manually reset by depressing a round reset plunger on the top of the protector. There is no provision for manually tripping this protective device. The generator control circuit breaker protects the bus in the event of a short or malfunction in the generator control panel. It prevents the generator from motorizing. Reviewing the protective devices in the generator output and control circuits, we find that any time the reverse current circuit breaker, overvoltage protector, or the field circuit breaker trips, they will open the generator field and remove the generator from the bus. If the generator field is opened, there will be no voltage or amperage output from the generator. The generator control circuit breaker protects the bus and the generator in the event of a malfunction in the generator control panel or generator. The generator control circuit breaker protects the bus and generator from a malfunction in the generator control panel or the generator field. The overvoltage protector will trip on full field voltage application and removes the generator from the bus. The field circuit breaker will trip with a heavy current flow in the generator field. It is also the only manual method to open the generator field. When tripped, it will remove the generator from the bus. The reverse current circuit breaker trips at 300 amps reverse current and removes the generator from the bus. When the voltmeter selector switch is in the bus position, power is provided through a 10 amp fuse through a selector switch to the voltmeter. This fuse only protects the voltmeter in the bus position. When an individual generator is selected, voltage for that generator travels through the ammeter positive fuse to the voltmeter. This fuse will protect the voltmeter when in a selected generator position. Ammeters connected across a shunt in the generator output permits reading the load placed on individual generators. Each ammeter is protected by a positive and negative fuse. These fuses are located on the side panels inside the main junction box and are easily accessible in flight. It should be noted that the ammeters can indicate generator load only. Some minor changes have been made in Group 2 aircraft electrical systems. 1. The generator output is now 350 amps. 2. There are better protective devices. And 3. The emergency light switch has added functions. Taking a Group 1 basic DC electrical drawing, and with some minor modifications, we now have the Group 2 system as shown here. All of these changes will be covered in detail later. The Group 2 generator has been uprated to 350 amps, but is completely interchangeable with the older generator. The only change is the installation of a thermal switch, trade name PlugStat, embedded in the generator case to sense temperature. The PlugStat is connected to a red warning light in the cockpit. During an overheat condition, the light will illuminate, but it will not affect generator operation. It simply warns of a possible overheat condition. In the Group 2 aircraft, a generator circuit breaker replaces the reverse current circuit breaker and the overvoltage protector. The generator circuit breaker provides the following protection. 1. Reverse current in excess of 300 amps. 2. Short to the generator supply line. 3. Excessive generator voltage. And 4. A generator overload. This overload protection does not exist in the earlier system. The generator circuit breaker is located in the main junction box in the same location as the Group 1 reverse current circuit breaker. If tripped, it may be manually reset by depressing the plunger on the top of the unit. Tripping may be accomplished manually by depressing the trip plunger, or naturally it will trip due to an electrical malfunction. The generator circuit breaker may be electrically reset from the cockpit by momentarily depressing a reset switch on the generator in-op panel. The generator circuit breaker will trip off with a flow of 300 amps of reverse current. The fault detector panel is located in the forward baggage pit and works in conjunction with the generator circuit breaker. It detects generator high voltage and trips the circuit breaker. 33 volts is the trip value if a single generator is supplying the aircraft. As more generators join the system, a locator bus allows the fault detector to find the generator with the highest voltage. Now the trip value is reduced below 33 volts, according to current unbalance from the respective generators. In comparing the protective devices for the Group 1 and Group 2 systems, we find that the generator control circuit breakers and the generator field circuit breakers have the same protective function and physical location. The individual functions of the reverse current circuit breaker and the overvoltage protector in Group 1 aircraft have been combined in the generator circuit breaker in the Group 2 aircraft. In addition, the Group 2 generator circuit breaker in conjunction with the fault detector panel provides improved bus overvoltage protection, grounded generator feeder protection, and excessive overload protection for the generator. The generator inoperative panel, outlined in blue, is located above the generator ammeter voltmeter panel, to the right of the duct pressure gauges. Here are the 4 red overheat warning lights, located on the bottom of this panel, giving the overheat warning from the generator PlugStat. Located just above the warning lights are the 4 momentary toggle-type reset switches that will electrically reset the generator circuit breaker. Above the reset switches are 4 amber generator inoperative lights that will illuminate whenever a generator is not on the bus. Power to illuminate the generator inoperative and overheat warning lights is taken from the two circuit breakers on the secondary bus on the main circuit breaker panel. The power to reset the generator circuit breaker is taken from the generator control circuit breaker through the reset switches. In the event of total electrical failure in the Group 2 aircraft, emergency power to operate the flight instruments is obtained from two engine-driven alternators. We also provide DC power from the battery to illuminate the flight instrument warning lights in case of alternator failure. For a heading device in the Group 2 aircraft, we utilize the C2 gyrus and compass as a directional gyro, here added in the blue area. But DC power from the battery must be provided to energize a clutch to allow disengagement of the heading card from the gyro when changing heading. This concludes the DC-6 DC electrical system.